We had some of the greatest times in that class.
Wow.
Yeah. All right. What's the answer to this one? All real numbers. Okay, so 3x plus 12 minus 2, and then equals 5x plus 10 minus 2x. And so I get 3x plus 10 equals 3x plus 10. Now some of you stopped right there. And you recognize that's fine. Sometimes you kind of keep going. You don't really look at the whole thing. Subtract 3x. 10 equals 10. It's still the same thing. As long as you have the left side equals the right-hand side, you say all real numbers. Well, this equation has a name. We call it an identity. An identity is an equation in which the answer is all real numbers. Everything will work. We are going to do trig identities today. Okay, trig identities. And on that sheet I gave you, it says trig identities, relationships, and formulas. Well, the very top one says reciprocal identities. Well, the first one is what? Cosine of theta equals what? Or no, the first one's not cosine, it is cosecant. So if you think of that as an equation, what makes it true? Everything. It doesn't matter. Like cosecant of 30 is 1 over sine of 30. Now, I know you don't think of that as an equation that you solve, but that's an identity. They're interchangeable. I can take anywhere there's a cosecant, I can replace it with 1 over sine. Everywhere there's a 1 over sine, you can replace it with cosecant. So that left-hand side are all identities. Okay, except those last ones, they refer to relationships, but they're the same thing. We can replace one side for the other. The Pythagorean identities are probably the ones you're least familiar with. Okay, and we'll talk about those in a second. But we're going to talk about, we're not really going to verify the even and odd identities, but we're going to verify a trig identity and show how to do that. Okay, that's kind of our goal today. This just lists what you have on your paper. You need to know and be able to use all of these. Quotient identities, especially important. Tangent is the same as sine over cosine. And cotangent is the same as cosine over sine. Don't lose this, especially if you take out next year. You'll want this, and I won't give you another one, so don't come ask me for it. This is your one and only. Okay, so if you lose it, you're on your own for that. Now, for the you got your Pythagorean identities, then you got your even odd. There's only two functions that are even. You know those at this point. Hopefully you know from the test. Cosine and secant. Those are the only two that are even. All the others are odd. All right, with these Pythagorean identities, go ahead and write that down. Sine squared x in your notes plus cosine squared x equals 1. Yeah, we need actual calculators. All right, that is the base identity. Sine squared plus cosine squared equals 1. But you can rearrange it and use that. So what does sine squared of x equal from that equation? It would be the same as 1 minus cosine squared. You would just subtract cosine squared. So if you ever have 1 minus cosine squared show up, you can replace it with sine squared. Cosine squared is going to equal what? That's going to equal 1 minus sine squared. So from that 1, you have your two other versions. Okay, you just move some things around. You isolate sine squared. You isolate cosine squared. These are all identities. Okay, so if you ever want to take cosine squared and replace it, you can replace it with 1 minus sine squared. That is only for cosine squared. Cosine of x. You cannot say cosine of x equals 1 minus sine of x. That is not true. That is not true. Only the square. Okay, only square. All right, and then we'll do the same thing with the second and the third one. The second one is 1 plus tangent squared equals secant squared. There's two other ways we can rearrange it. I can say tangent squared of x equals secant squared of x minus 1. And I could say 1 equals secant squared of x minus tangent squared. And then do the same thing for that third one. 1 plus cotangent squared x equals cosecant squared. And so for this one, I could say cotangent squared x equals cosecant squared x minus 1. And I could say 1 equals cosecant squared x minus cotangent squared x. Any of those could come up. You're probably going to need this sheet the first few times you start doing these things until things start to click in your head. All right, now before we get into some actual identities, let me just talk about something here. You know from that sheet that cosecant of theta equals 1 over sine theta, correct? That same relationship will hold for if both sides are squared. So cosecant squared of theta is going to equal what? That's going to equal 1 over sine squared. Okay, 1 over sine squared. And if you think about this, tangent of theta equals what? Tangent is sine over cosine. So tangent squared would be the same thing as what? Sine squared over cosine squared. All right, so those things are going to come up within the course of what we're doing. Just make sure you're familiar with that. All right, this is the first identity we're going to look at. All right, verify that trig identity. Write that down. Write that down. Eli, here's your test. All right, make things a little bit easier on that. All right, a lot of times you're going to, first of all, you're going to ask you, is this an identity? And I'm not going to give you ones that aren't at all. Basically, I'm going to tell you this is an identity, which means any angle would work. I'm basically telling you the left-hand side is equivalent to the right-hand side. Your job is to prove that to me using already known facts to simplify this and show me that they're equal. Okay, that's your job. This little half sheet of paper that you have goes through the procedures because you are not solving an equation. And this is the hard thing. The first few times we talk about this, it kind of gets stuck in your head because you think you're solving an equation. We're not. We're not trying to find the answer. Because I'm telling you right now, the answer is all real numbers. You can plug in any angle and it'll work. Your job is to show me why it works. Okay? Now there's some procedures to kind of go through here to make it easier. All right, you still do your math. You need to know your fractions. If you struggle with fractions, this will be difficult. You have to get better at those. Okay, you have to know your identities, like what cosecant equals, what tangent equals. That will help you. All right, and now it says about halfway down, it says steps for verifying identity. These are just helpful. They're not all set in stone, and you don't necessarily use all of them. And you may go in a different order, it doesn't matter, but it gives you something at least to look at. Since this is an identity, this is not an equation, You're not trying to isolate anything. You are only allowed to work, you cannot cross the equal sign. You cannot move anything from one side to the other. You have got to work left side only and right side only, because theoretically, we don't know this is equal, okay? We don't know this is equal, so I cannot move from one side to the other. You have to stick with the left-hand side and the right-hand side. My job is to make one side look exactly like the other side, okay? Now, you can work with both sides, you just can't cross over. All right, so number one, it says to do what? Start with the more complicated side. Sometimes they both look equally complicated, but more often than not, it'll be pretty obvious. Now, to me, since I got a fraction, the more complicated side is the left-hand side. We want to take that and we want to make sure that we're going to start with that. Number two, stay focused on the answer. It's not going to make a lot of sense till we do a couple of these. All right, you kind of have to have an idea of what you're shooting for, so that there's different paths you can take. One path will lead you, towards what we're looking for, and other paths will take you away from it. And then we'll talk about number 3, 4, and 5 as we work through here. All right. Any ideas what we can do? And it's okay to make mistakes. This is one thing here where you're going to make mistakes. You're going to take wrong paths. Tyler.
My first step was turn secant of theta into 1 over cosine of theta.
You can do that, but I'm not going to do that. Okay. And here's the thing: you can take different paths that will work, and if it works, that's fine. There's going to be easier paths than others. Now, let me go through one thing dealing with fractions. If I have a plus b over c, can I write that as a over c plus b over c? Is that mathematically legal? Yeah, you got that denominator, you can split it up. Can I take a over b plus c and write that as a over b plus a over c? Can you do that? No. Can't. Let's see if I can give you something that works. Here's something that helps you. Let me throw some numbers in there. Well, let's make sure. All right, think about this. If I have 2 over 3 plus 4, well, that is 2 over what? 2 over 7. According to what we just said, can I make that? Okay, if I said those are equal, then this would also have to be what? 2 over 7. Well, that's 2/3 plus 2/4. That's like 0.6 plus a half. That's bigger than 1.
Oh, I just have an idea.
Okay, all right. 1 second. So, and this is going to come up. So can we take that and break it apart? No? The first one's okay. What's your idea, Joe?
Do what you said first. So have secant of theta over secant of theta plus 1 over secant of theta.
Okay, we can just split this up.
And the left side's going to be 1.
And secant theta over secant theta is 1. And then what's 1 over secant?
Equal to cosine.
1 over secant is equal to cosine. Okay. Is that the only way? Absolutely not. But for this one, it might be the easiest way. And that's all you got to do. So what did we just show? Left-hand side is exactly the same as the right-hand side, even though it initially doesn't look like it. So we're done. That's all I got to show. Different ways to get there. Tyler, you probably would have gotten there the other way. Okay, probably would have gotten there the other way. And we'll get to that. All right, second one. Somewhere. There it is. There. All right, copy that down. Keep these little sheets in front of you just to kind of have a reference. Secant of theta minus tangent of theta. That would be times sine of theta equals cosine of theta. All right, well, clearly, number one says start with a more complicated side. Which side would that have to be?
The right.
The right side, yeah, the cosine. The left side, clearly, that is more complicated. All right, as you look at that, is there anything that just, can you subtract those the way they look? Like, is there any way to do anything at this point? No, not really. Okay. Number 2 says keep the end focused on the answer. Well, that doesn't help me a ton right now. All right, number 3, here's the key thing. Do not ever stop an identity until you've done step 3. Now, what does it say? Convert the sines and cosines. Here's what that means. Okay. Take anything that is not listed as, and convert it so it's written in terms of sines and cosines. Anything that can be. What that means, secant is the same as what?
1 over cosine.
1 over cosine. Start with that. Secant is the same with 1 over cosine. Tangent is the same as what? Sine over cosine. So you cannot stop without major penalty an identity until you have at least tried that. That doesn't mean that will always be the perfect step or the first step, but when you get to a point and you're like, I really can't go any further, you cannot, don't leave a tangent, don't leave a cosecant, don't leave a secant, don't leave any of that until you've converted the sines and cosines. All right, we're going to try to simplify this. That's a multiplication. How can I write it a little bit nicer? What's sine over cosine times sine equal to? Sine squared. Sine of theta times sine of theta is sine squared of theta over cosine of theta. All right, I'll say this a good bit. Do the math. Subtract those two. What does that look like when I subtract those two? Now, that doesn't mean you're necessarily going to get an answer, but you can at least represent them as one fraction. So what's 1 over cosine of theta minus sine squared over cosine? Do they have the same denominator? Yeah, so I can write that as 1 minus sine squared theta over cosine of theta. All right, this is where like that step 2 comes involved. Keep focused on the answer. What's the only thing on that right-hand side? Cosine. So we have got to make that look like just cosine of theta. Anybody know the next step? Aaron.
Convert the 1 minus sine squared to a cosine squared.
We wrote that down earlier. That is one of your Pythagorean identities. 1 minus sine squared theta is going to equal cosine squared. Let me see. And you don't have to write this little fact over here. This is just since we haven't done this a whole lot. You just have to make sure each step is mathematically valid. Well, 1 minus sine squared, I can replace that with cosine squared. And then the denominator is cosine, so that just cancels. It's like x squared over x, and then that's just cosine of theta. So that's the left-hand side, that's the right-hand side. Anytime you have a 1 and you have something squared, it's probably part of an identity that can be replaced. You may or may not need it, but you should always at least investigate it, especially sine squared and cosine squared. Okay, so 1 minus sine squared is cosine squared. That's what we want. We're done. Okay, we are done. All right, copy down number 3. Sine of x minus cosine of x times sine of x plus cosine of x is equal to 1 minus 2 cosine squared of x. More complicated side would be left-hand side. All right, what's going on there? That's a multiplication problem. So right now, I can't really do anything. Multiply them together. Multiply them together. What does that give us? That's a FOIL problem. Sine of x times sine of x sine squared of x. Sine of x times cosine is plus sine of x, cosine of x. Cosine of x, negative cosine of x times sine of x is, I'm just gonna reverse the order. And now negative cosine times positive cosine is minus cosine squared. Do the math, simplify anything you can, because what do those two middle terms add up to? 0, and what am I left with? I'm left with sine squared of x minus cosine squared of x. All right, here's where I tell you to keep step 2 in mind. Look at your answer. Look at what we're trying to show. What is the only trig function on the right-hand side? The only trig function is a cosine. So I got to get rid of the sine on the left-hand side. How do I get rid of sine squared? Okay. Aaron.
Sine squared equals 1 minus cosine squared.
From our Pythagorean identities, sine squared equals 1 minus cosine squared. So that means wherever there's a cosine squared, I can take it out, replace it with 1 minus cosine squared x. Why would I want to do that? Because the right-hand side does not have anything to do with sine. You want to rewrite it in terms of something else. All right, what does that simplify to? 1 minus cosine squared minus cosine squared? That is 1 minus 2 cosine squared. Is that what we wanted? Yep. 1 minus 2 cosine squared x. And now we are done. Now, like I said, I'm putting this little fact in green because we're not as familiar as we will be. You don't need to put that down as part of you unless it helps you. But you need to make sure every step is logical. Okay? Because you'll start to make up math to try and get to an answer if you get confused. So make sure every step is logical. All right. Take a second, just kind of on your own, think about what you can do. I wouldn't write anything down just yet. But just kind of think what your first key step would be. And there's going to be a lot of different ways you can start a problem, and you can eventually get there. There's going to be some that are quicker than others, but doesn't mean you're necessarily incorrect. Now, right now, like at this point, I look at that and I have no reason to believe that the left-hand side is exactly the same as the right-hand side. Like, no reason to believe that. That's why we got to go through it. All right, ideas. Caleb, what do you think?
Use the quotient identities on tangent, convert to sine over cosine.
So take tangent and make it sine over cosine? Okay, I agree with that. There's another form. I'm not going to say one is better than the other. What's the other one? Or anybody seeing anything else? Maybe nobody else sees it. Okay, 1 plus tangent squared is the same as secant squared. That's also an option. All right, we'll go with Caleb first. And then I'll show you how to do the other one. All right, he says replace tangent with what? Sine over cosine. So take this and make this 2 tangent becomes sine of theta over cosine of theta. 1 plus. All right, you can replace tangent squared. What will that become? Sine squared over cosine. So convert, if you're going to convert one thing to sine and cosine, convert everything to sine and cosine. All right, that is a correct first step. Now, how do I go further? You have to add the denominator together. Okay? 1 plus sine squared theta over cosine squared theta. Well, how do I add them together? I have to get a what? Common denominator. So what is that going to make that 1? Cosine squared over cosine squared. Right? You got it. The better you are with fractions, the better this section is. Well, also be careful here because I get a lot of people make a mistake in the numerator. 2 times sine of theta over cosine theta is equal to what?
2 sine theta over cosine theta.
Yeah, 2 only goes to the numerator. So it's 2 sine of theta over cosine of theta. All right, we said 1. We're going to get a common denominator of cosine squared theta. And that's going to become cosine squared theta. I can't really do anything to the top yet. All right, this here, I'm going to have a fraction, this numerator, divided by this denominator. I just need to simplify this a little bit more before I go anywhere else. Well, I do have a common denominator, right? So I'm going to keep this as 2 sine of theta over cosine of theta. All right, this can be written as cosine squared theta plus sine squared theta all over cosine squared theta. All right, at some point, I'm going to have to do my multiplication. I'm going to have to take the numerator, multiply or divided by the denominator. But I want to do one thing first. There's one identity that I can use to make this a little bit simpler. Does anybody see? 1. 1 goes where?
Cosine squared plus cosine.
Yeah, sines, but we originally wrote it as sine squared plus cosine squared, but obviously you can switch the order. That equals 1. So that means this whole numerator is equal to 1. I can take the whole thing out, replace it with 1. So here I'm at 2 sine of theta over cosine of theta divided by 1 over cosine squared theta. All right, now at some point I can't, obviously that doesn't look like the right-hand side, does it? Because that's all in one fraction, or no fraction at all. So I have to divide. So take 2 sine of theta over cosine of theta times. Okay, keep the first one, change it from division to multiplication, flip the bottom one. So it's cosine squared theta over 1. You are always in these things looking to cancel. Because anything in the numerator will cancel anything in the denominator, provided everything's being multiplied, which it is. So what cancels? This cosine with the cosine squared, this means there's 2 of them up there, so there's what? 1 of them, and what do I have left? 2 sine theta, cosine theta, which is back over on the other side. Oh, eventually. I didn't touch that right-hand side. Didn't need to, but I ended up with the same thing. Okay. All right, now, this is the exact same thing. Don't even need to write this down because I at least want to go through this. What was, Nick said something different. Said take the 1 plus tangent squared out and make it what? Secant squared. So it's 2 tangent of theta over secant squared theta. Well, it's obviously not the final answer, but what can I do from here? Think about it.
Make the top 2 times sine of theta over cosine of theta, and the bottom 1 over cosine of theta.
Yeah, at some point,
And then you would just multiply the same way you did before, or divide the same way you did.
convert to sines and cosines. Convert to sines and cosines. So now that gives me 2 sine of theta over cosine of theta times cosine squared theta over 1. That cancels. Was that easier? Probably. But here's the thing. If you don't recognize that, I'm going to tell you probably about 80% of you will do this first. 80% of you will convert to sines and cosines and go through those steps. 20% of you will see that. Doesn't mean one's better than the other, it just means one's maybe a little bit shorter than the other. All right, I want to do one more. One more. I'm just gonna do this now because I know it'll help me. Secant squared is 1 over cosine squared, so it's really 2 times that, and I can just write it as 2 over cosine squared x. So I'm gonna mess with the right-hand side. Obviously, it doesn't equal the left-hand side, but you can work with both sides independently. So I'm gonna do that. All right, a couple key things here. 1 minus sine of x does not equal cosine of x. Does not equal. 1 minus sine squared equals cosine squared. But they cannot just drop the squared and say it's the same. It is not. So you cannot replace that. All right, what can we do though? What can we do? On the left-hand side, they ask me to add 2 fractions. How do you add fraction? You have to have a what? Common denominator. Do the math. Get a common denominator. What's that common denominator going to be? 1 over 1 minus sine of x. What do I have to multiply this one by? I'm going to multiply it by 1 plus sine of x, which means I need to multiply the top by 1 plus sine of x. And what do I need to do to the denominator? It needs to be multiplied by 1 minus sine of x. And then I got 1 times 1 minus sine of x. All right, at this point, it doesn't look anything like the right-hand side. But we'll get there. All right, get that down and just think about what we can do next, and then we'll go through it. All right, with this, this becomes 1 plus sine of x plus 1 minus sine of x over 1 minus sine of x times 1 plus sine of x. I can write it as 1 fraction. Simplify the top. This doesn't look anything like the denominator. So what can I do to the bottom? What can I do to the denominator? At this point, if you're stuck, foil it together. Foil it together. What happens to the top though? What is 1 plus sine of x plus 1 minus sine of x? That's just going to equal what? 2, because you wrote it up with 1 plus 1. The sine of x and the negative sine of x here add up to 0, so you're left with 2. Foil the denominator. Foil that. 1 minus sine of x times 1 plus sine of x. It's going to be a difference of squares. What am I left with? 1 minus sine squared of x. Okay, if you have a 1 and you have something squared, look for one of your identities. What is 1 minus sine squared of x equal to? Cosine squared. So 1 minus sine squared of x equals cosine squared of x, which gives me 2 over cosine squared x. And that's what we want, right? Done. It's an identity. So technically, what's the answer to this? All real numbers. Anything will work. Why do we do these identities? Because they're fun. It's like a puzzle. We just try to solve the puzzle. That's really it. Do not do these problems. I'm not going to give you any homework. I haven't done my homework. You don't get any homework today. That doesn't matter. Doesn't last forever. Alright, so no homework. We'll continue these tomorrow. It usually takes a day or two to make them sink in. Alright. How do I turn this off?
How you doing?
Hey, hanging in.
Any updates on the day?